Hello, welcome to PhyzQuest. So this is the solution video for CSIR NET December 2019 Part B, question number 5. So question number 5 is, there is a circuit given. D is an ideal diode. The source voltage Vs is equal to V0 sin omega t is a unit amplitude sine wave and the resistance Rs is equal to RL. We need to calculate the average output voltage VL across the load resistor RL. 4 options are given and we need to choose the correct option. So this question is based on the topic electronics and the concept involved here is diode. So this is the given circuit. Here the voltage source Vs is a sine wave which is equal to V0 sin omega t. Now a sine waveform will be like this. This is the, here it consists of positive and negative half cycles. Okay, so the behavior, this is the behavior of a sinusoidal wave. Now here, when such type of source is applied to a circuit which contains an ideal diode, the flow of current within the circuit will be affected by the diode. This is due to the response of the diode to the AC voltage source. Now a diode has two characteristics. One is the forward biased and the other is the reverse biased. So its behavior will be different during positive and the negative half cycle of the voltage source. So how it will behave, let's look at it. During the positive half cycle of the voltage source, here the diode will be forward biased. That means it will conduct the current. So this means this is equivalent to a short circuit. Now current will, in this scenario, the current will prefer to flow through this path instead of passing through the parallelly connected resistance Rs. Why? Because when it is short circuit, there will be no resistance here. So now if the current is I, this I will be equal to Vs divided by RL. Why? Because this, after passing through the diode, the current will flow through this only this resistance RL. It will not pass through Rs. So I will be equal to Vs by RL. So in this case, the output voltage VL will be equal to I into RL. Now I we have already calculated as Vs by RL, so this will Vs by RL multiplied with RL. Now RL will get cancelled. Ultimately we will get it is equal to Vs, which value is already given as V0 sin omega t. So this is the behavior, this is the output voltage for the positive half cycle. Now let's talk about the negative half cycle. In negative half cycle, the diode is reverse biased. So when it is reverse biased, it will not conduct the current. So this will act as an open circuit. So that means current cannot flow through this diode. So here what will happen is current will flow through this parallelly connected resistance Rs and will go through the resistance RL. So here when we calculate the current will be equal to Vs divided by Rs plus RL. This is by voltage divider rule. Now again here the output voltage across the load resistance RL will be equal to I into RL. Now putting the value of the current, it will be Vs by R divided by Rs plus RL into RL. Now it is already given in the question that this resistance, load resistance RL and the resistor Rs both are equal. So in place of Rs, if we put RL, it will be 2RL and already there is a RL here. So RL would get cancelled. Ultimately the answer will be Vs by 2, which is equal to V0 by 2 sin omega t. So this is the output voltage across the during the negative half cycle. So we have got the output voltage across the load resistance RL during the positive and the negative half cycle. But the question here is we have to calculate the average output voltage across the load resistor RL. So how to do the average? See, in any average value, whether voltage or current, in case of a sine wave, is defined as the area under the waveform with respect to time. So now how to calculate the area under the curve? Area under the curve is mathematically calculated by integrating the waveform for that period of time. Since now here we have different values of instantaneous output voltage for the positive and the negative half cycle. We have already done that. So here we will have to do the integration for the positive and the negative half cycle separately and take the average over the whole period of time. Now here, instead of omega t, if we choose omega t is equal to theta, here the positive half cycle will be from 0 to pi and the negative half cycle will be from pi to 2 pi. So this whole time period will be a duration of 2 pi. So we can calculate the average voltage as V average is equal to, first of all, it will be for positive half cycle, it will be integration from 0 to pi. For positive half cycle, it is V naught sine theta d theta. In place of omega t, I have used theta. So here actually the formula is VL d theta. VL for positive half cycle, it is V naught sine theta. Plus for negative half cycle, it is integration from pi to 2 pi, V naught pi to sine theta d theta. And this average, whole average will be taken over a period of 2 pi. So we have to multiply 1 by 2 pi here. So when we solve this, this will be equal to, here in this integration, V naught is a constant number. So we can take out V naught from both the integration and the bracket. So this will be equal to V naught by 2 pi. So now the integration of sine theta d theta is minus cos theta. So this will be, the first term will be minus cos theta from 0 to pi, and plus here there is a half is there, so we can take out half. So it will be half minus cos theta from pi to 2 pi. Now we have to put the values here, put the limits. So this will be equal to V naught by 2 pi. Now there is a minus sign here. In the first term I am talking about, the minus sign is there. So now minus here, the cos pi will be equal to minus 1 and cos 0 is equal to 1. So the first term will be minus of minus 1 minus 1. Now again in the second term there is already a minus. If you take it out, so it will be minus half. So again here cos 2 pi is equal to 1 and cos pi is equal to minus 1. So since there is already a cos 2 pi is 1 minus of cos pi, which is minus 1. So minus will be plus, it will be 1 plus 1. So here again this will be equal to V naught by 2 pi. The first term will be 2 and the second term will be, there is 1 by 2 into 2, it will be 1. So it will be 2 minus 1. So upon further solving, the answer will be V naught by 2 pi. So this is the average output voltage across the load resistor RL. Now let's look at the option. Now if you look at the option, you can see that option A is matching with our result. So the correct answer for this question is option